Today, we're going on a journey through the history of artificial intelligence. But we're not just going to look at a timeline of dates. Instead, we're going to trace the evolution of the big ideas, the core concepts that got us from an abstract philosophical question to the incredibly powerful AI we see everywhere today. All right, let's get into it.
So where do you even begin? Well, before anyone wrote a single line of code, the whole field of AI started right here with this one massive question. What does it even mean for something non-human to be intelligent? It's a question that forces us to really think about what it means to reason, to understand, to think. It's not just a technical puzzle, it's deeply philosophical.
So you've got this big, fuzzy philosophical question. Then, back in 1950, Alan Turing comes along and just cuts right through all of it with a beautifully simple, practical idea. He basically said, forget trying to define thinking. Let's just ask, can a machine have a conversation that's so good you can't tell if it's a machine or a person? That's it. That's the test. And that simple, concrete goal has been a driving force for AI research for decades.
Okay, so with that as our North Star, let's look at how the first pioneers actually tried to build an intelligent machine.
The first big bet was on pure, cold, hard logic. The idea was, hey, maybe intelligence is just a really, really complicated form of calculation. If we can just define the entire world with a set of formal rules, a machine should be able to reason its way through any problem, right?
This was the logicist tradition, or what some people now affectionately call good old-fashioned AI. The core belief was that human thought could literally be bottled into a system of symbols and rules. If you just got the rules right, boom, you'd have intelligence.
And you know what? This approach led to some absolutely stunning results. When chess legend Garry Kasparov played against IBM's Deep Blue, he saw something that just floored him. The machine made a move that wasn't just about the immediate advantage, it felt deeper. It felt like it had a sense of danger. Now, this wasn't magic. It was the raw power of searching through an unimaginable number of future moves, which was a huge strength of this logic-based approach.
And just to give you a sense of the scale we're talking about here, I mean, look at this. These pioneers weren't messing around with tic-tac-toe. Checkers has something like 500 quadrillion possible positions. For chess, the number of possible games is bigger than the number of atoms in the known universe. That's the kind of insane complexity they were tackling head-on.
And this is basically the mic drop moment for that entire era. After 18 years of non-stop computation, a team finally solved the game of checkers. They proved that if both players play perfectly, every single game will end in a draw. It was a monumental achievement, and it proved that for a world with perfect, clear rules, logic and search could be unstoppable.
But here's the catch. The real world isn't a checkerboard. It doesn't have perfect, clear rules. The real world is messy, it's uncertain, and that's where this purely logical approach started to hit a wall. I mean, think about it. Just crossing the street isn't a logic problem. A doctor doesn't say, if you have a fever, then you have the flu. They say, well, you probably have the flu, but it could also be... That kind of maybe thinking, that reasoning with uncertainty, was pretty much impossible for those early systems.
This chart just perfectly captures the huge mental shift that had to happen. We had to move away from a world of black and white, or of true or false, and into a world of possibilities, a world of shades of gray.
And so AI got a new tool in its toolbox, probability. This was the game changer. It gave machines the ability to work with incomplete information, to weigh the evidence, and to make the best possible guess. Suddenly, a whole new world of real-world problems opened up for AI to tackle.
And this whole shift, this move towards dealing with messy real-world data, paved the way for the next great era, the one we're living in right now, the rise of machine learning.
The entire philosophy just got flipped on its head. Instead of human experts trying to painstakingly program all the rules into a machine, the new idea was, what if we just give the machine a ton of data and let it figure out the rules for itself? The goal was no longer to build intelligence, but to let it emerge.
So what was the fuel for this revolution? Data. Just an unimaginable amount of data. Trillions of words from the web, billions of images, countless hours of video. The internet essentially became the world's biggest classroom for this new kind of AI.
So how does a machine actually learn? Well, here's a simplified way to think about it, a method kind of like boosting. Imagine you have a student try to solve a problem. Then you bring in a second student, but they only focus on the mistakes the first one made. Then a third student comes in and focuses on the second student's mistakes, and so on. You're not relying on one genius, you're combining a bunch of specialists. And together, that team is way smarter than any individual. That's the basic idea.
So, that brings us to today. And what's so fascinating is that we haven't actually thrown away the old ideas. The most powerful AI systems today are a synthesis, a combination of everything that came before.
The most advanced AI uses machine learning to perceive and understand the world, probability to handle all the uncertainty, and then it uses logic to structure its plans and take action. It's the combination of all three of these big ideas that makes today's AI so incredibly capable.
I mean, just look at this. These are autonomous helicopters that learn to perform these unbelievable acrobatic maneuvers. No one programmed them how to do a flip. They learned entirely on their own through trial and error, what we call reinforcement learning. And in the end, they were way more skilled than even the best human pilots. It's just amazing.
And it's not just about action, it's also about perception. You and I can look at a photo and instantly tell that one path is sloping up and one wall is curving away. We see the 3D shape. Well, AI is now learning to do the same thing just by analyzing the patterns and textures in a flat 2D image. It's learning to perceive the world in 3 dimensions, a lot like we do.
So we've gone from the perfect, ordered world of the checkerboard to the messy, boundless data of the internet. We've seen AI evolve from a pure logic machine to a system that can actually learn and adapt. But you gotta know, this journey is far from over. It all makes you wonder, right? We've had these massive shifts in thinking, from logic to probability to learning. What's the next great idea? And as AI keeps evolving, how is that going to change our answer to that very first question? What does it really mean to be intelligent?